relativity theory about time. Does time actually exist? Some physicists believe time is an illusion. It really doesn't exist at all. But when we research time further, we discover that it is actually just a man-made measurement, like a ruler. It measures length. In physics, even in relativistic effects, time is not a physical thing. What this means, it's not matter, because matter is made up of elements. Time is not real, it's an illusion. When Einstein developed spatial relativity, he based his original ideas about light with time. His famous statement, "Nothing can travel faster than light." He believed at the time that the speed of light relative to time and space travel, that when approaching light speed in a ship, time slowed down with it. That time stopped at light speed and everything conjectured in the universe, meaning all repeating in a cycle or rotation that were measured with that specific time, measured all stopped also. That his ship, that tiny vessel 250 miles up in space, stopped the universe. Thus was his claim that the universe is governed by a universal speed limit. A field scientist believed layers, the spacefield vacuum, bottom layer of space. That space, since it is an almost zero-point energy realm, that the energy at the Higgs field level doesn't have enough detectable energy or gravity field fluctuations, that it could affect a superluminal vessel traveling approaching light speed acceleration. Thus the ship is not affected. This idea changes the way we look at space travel. Though vacuum acceleration is not a common practice in explaining space travel inside the universe, that in effect, energy is also preserved. This means propulsion engines will carry on having the warp drive capacity. At these velocities is where the Alcubierre warp bubble precedes itself. At such speeds deep within the space grid, travel corridors are formed separating the ship's position and resistance passing through the grid. A tunnel is formed. We know warp drive engines are being developed by inner space engineers for the direct purpose to develop light-speed motors. The bigger the motor, the faster the speed. Newtonian mechanics come into play when we recap.
Actually exists. Some physicists believe time is an illusion. It really doesn't exist at all. But when we research time further, we discover that it is actually
challenged his views. The expansion of the universe revealed truths that shook the very foundation of his groundbreaking work. As astronomers peered deeper into the cosmos, their observations led to revelations that contradicted Einstein's original theories, sparking debates among scholars about the nature of time and space. These groundbreaking revelations opened new avenues of thought as researchers began to question whether time travel was merely a fantasy fueled by the imagination of one of history's greatest minds. In this atmosphere of discovery and challenge, young minds emerged with fresh ideas inspired by the vastness of space, determined to reconcile Einstein's legacy with the enigmatic realities of modern astrophysics. As discussions continued to evolve, the boundaries between science and imagination blurred, leading innovators to dream of possibilities once deemed impossible, igniting a new passion for the exploration of time. The universe is expanding, a phenomenon that leaves many pondering how this relates to Einsteinian time travel theory, a groundbreaking concept that forever altered our understanding of space-time. As researchers explore the implications of this expansion, they consider whether time travel could allow us to traverse the vast distances of an ever-growing universe. The theory of time dilation suggests that as one approaches the speed of light, time behaves differently, creating tantalizing possibilities for what lies ahead in an ever-expanding cosmos. In this context, time is not merely a constant but a fluid dimension that can stretch and contract, influencing our perception of reality as we explore the mysteries of our universe. By studying these cosmic phenomena, scientists aim to unlock the secrets of time travel, seeking to understand how the fabric of space-time might be manipulated in an ever-expanding universe. As humanity progresses into new technological eras, the dream of time travel becomes increasingly tangible, fueled by discoveries about the universe's expansion and our place within it. energy density is constant in time.
It doesn't dilute as space expands. Instead, the same density fills more and more space, so the total vacuum energy increases, but the density stays fixed. This constancy is what causes accelerated expansion.
When has vacuum density been higher? Yes. In the past, the universe did experience higher vacuum-like energy densities, but not the same law we have today.
These happened during phase transitions, inflation era, very early universe. A scalar field, inflaton, created a huge effective vacuum energy,
Extremely high density, exponential expansion.
then it decayed, reheating the universe, matter and radiation.
Particle physics phase transitions. When the universe cooled, electroweak symmetry breaking, QCD confinement.
Each time the vacuum state of space changed, and the vacuum energy dropped to a new stable level, like settling into a deeper valley.
So historically, vacuum density was higher, dropped, stabilized to today's Koetsky superluminal condition. Superluminal travel becomes physically achievable when a spacecraft resides within a finite engineered region of spacetime, in which the vacuum energy density is asymmetrically structured, such that spacetime expands behind the vessel and contracts ahead of it. When the net differential expansion exceeds the light speed separation rate relative to distant observers, the vessel undergoes effective superluminal translation, while all local physical processes remain strictly subluminal.
Physics formal statement for theoretical framework, Koetsky superluminal condition.
A spacecraft can achieve effective superluminal propagation relative to distant inertial frames without violating local relativistic constraints if it is enclosed within a bounded spacetime region in which the vacuum energy field produces asymmetric curvature such that the induced spacetime expansion behind the craft exceeds the contraction ahead of it, yielding an apparent superluminal displacement of the craft's worldline while preserving. In an expanding spacetime, a ship may reach a specific velocity as the spacetime acts as a carrier force by the speed of the vacuum without wavature. As the ship harnesses the energy of the vacuum, it navigates through this cosmic conduit, pushing the boundaries of what is known about speed and travel. The crew, monitoring their instruments closely, feels the exhilarating rush as they breach theoretical limits, embarking on a journey into the unknown realms of the universe. In this magnificent expanse, the explorers find themselves on the brink of monumental discoveries, where the laws of physics seem to bend and stretch alongside their ambitions. With every decision, they venture deeper into uncharted territories, driven by the thrill of exploration and the promise of uncovering the secrets of the universe. Every discovery leads to new questions, and as they approach this solar system, the team is filled with anticipation for what lies ahead, ready to unlock the mysteries of the cosmos. As they prepare for landing, the vast unknown awaits them below, holding potential for adventure and the promise of life in a realm beyond their wildest. Planet Earth is a static environment that illustrates its storms and thunder. The vacuum space field is empty of Earth's atmospheric statics. As the storms rage over the surface, the atmosphere crackles with energy. Below, everything appears serene, yet a powerful force brews above, reminding us of nature's duality. The contrast between the vibrant Earth and the impending storm creates a captivating scene. The energy in the atmosphere builds, ready to unleash its fury upon the landscape. As lightning dances across the sky, a sense of anticipation fills the air. The stillness of the meadow is a stark contrast to the brewing tempest above, creating an atmosphere thick with emotion. In the barren desert, the winds whip through the air, signaling that a storm is on the horizon. As the first drops of rain touch the thirsty earth, a transformation begins, hinting at renewal and life. The coastline stands resilient against the relentless waves, embodying strength amidst the storm's fury. Each crash of the wave and every flash of lightning tells a story of the powerful forces of nature at work. In a world where theories about time travel ignited imaginations, Albert Einstein's ideas stood tall until new discoveries challenged his views. The expansion of the universe revealed truths that shook the very foundation of his groundbreaking work. As astronomers peered deeper into the cosmos, their observations led to revelations that contradicted Einstein's original theories, sparking debates among scholars about the nature of time and space. These groundbreaking revelations opened new avenues of thought as researchers began to question whether time travel was merely a fantasy fueled by the imagination of one of history's greatest minds. In this atmosphere of discovery and challenge, young minds emerged with fresh ideas inspired by the vastness of space, determined to reconcile Einstein's legacy with the enigmatic realities of modern astrophysics. As discussions continued to evolve, the boundaries between science and imagination blurred, leading innovators to dream of possibilities once deemed impossible, igniting a new passion for the exploration of time.